All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna carry on studying calculus. Sorry, I got distracted for a little bit because I noticed I'm looking at the sound levels in OBS, and my vocals are coming through pretty well. Fortunately, I've put that limiter on, so it stops it from peaking. And yeah, it's good to see that the vocals are coming in loud and clear, I guess. Give me a second. Okay, so yesterday we started learning calculus, right? But then I had to take a slight detour from calculus to learn some more basic things like slopes, how to calculate the slope of a line, and that was interesting. So okay, I realized later on that I didn't actually look into I didn't actually practice calculating the slope. Like, I know what the formula is, but I didn't practice actually calculating the slope of something. Right? We have over here. So the slope of a line is the slope of a line in the plane containing the x and y axes is generally represented by the letter m, and is defined as the change in the y coordinate divided by the corresponding change in the x coordinate between two distinct points on the line. This is described by the following equation. Now, okay, so I'm wondering. The equation they're talking about is this, by the way. Now, that being said, I'm wondering if this, how this ties back into. Give me a second. How this ties back into y equals mx plus b. I'm wondering if this is just a rearranged, what we just saw, if that is just a rearranged version of y equals mx plus b. I guess I'll find that out once I go deeper into this topic, which is solving equations, because I haven't done this in ages. When I say ages, I'm not even kidding. I haven't done this since like back in my school years. I'm trying to remember when exactly I'd done it. I think I haven't done this since like middle school. Because like ever since then, I never needed to do it. Even once I started using math in doing like game dev stuff, I never really was in a situation where I had to solve, or to be more clear, I never was in a situation where I had to rearrange an equation. I've very, very rarely been in situations where they'll give me an equation that's off the form, so-and-so variable and so-and-so variable, and there's whatever arithmetic operations going on, equals 0. Like, I've very rarely been in those kinds of situations where I actually need to solve an equation. I usually, or rather not, I don't know if solving the equation is like the right term to use there. Rearranging an equation. I've very rarely been in a situation where I had to rearrange an equation, and so I kind of just forgot how to do it. So I want to learn how to do it again, at least for simpler stuff. Of course, like this can be applied to much more complex things as well, but I'm not trying to do that. I'm trying to solve algebra equations, rearrange algebra equations, more specifically, because like that's what I deal with in like game dev stuff, right? So there's certain rules surrounding it. Like when you move numbers around, then operations kind of change. There's a specific way of doing that I need to just learn again. Oh, hold on. I wonder if that also comes under solving, or if that has like its own topic. Is that called rearranging an equation? Let me see if there's a Wikipedia entry for that. Give me a second. Equation solving. Okay, so there is an equation page. Let's open that up. By the way, even today's stream is going to be a whole lot of just this theory stuff. I need to learn some of the basics of calculus before I get into deep learning stuff, because the instances where I did go deeper into machine learning and deep learning, I definitely saw calculus there. And so I was like, okay, I kind of need to learn this. I even saw like the slope thing, and I had no idea what they were talking about. Like, I know what a slope is, but just in like the practical sense, I didn't know how exactly it's represented mathematically. So mathematically, I didn't know what exactly a slope would be, or how you would represent the slope of a line, or how even a line would be defined. I had to look up a lot of these things. Okay. So equation. All right. Great. There should be algebra, systems of linear equations, and then geometry. I think parametric equations. Wait, there's a differential equation. A differential equation is a mathematical equation that relates some function with its derivatives. So I think I'm going to be using this in calculus. Assuming I don't have the, what do you call it? Assuming I don't have the formula just given to me, because I've been fortunate enough that each time I read about like a new formula, a new equation, a new algorithm or something, they say that, okay, the equation is in the form so and so, but it can be rearranged as a parametric equation in so and so form. So for example, if you look at the Rose curve or even the Lissajous curve, you'll find a similar situation going. You'll find a similar situation with like a lot of other equations. So they'll tell you that, oh, it's in the form so and so, but it can be rearranged as a parametric equation. So you can do it can be rearranged as a parametric equation that looks like this. So they give you the equation, which is why I've very rarely had to actually solve the thing myself. I just need to use the equation, which is great. It's convenient. It's time saving. Okay, I need to look into. Okay, a parametric equation for a curve expresses the coordinates of the points of the curve as functions of a variable called a parameter. For example, so and so are parametric equations for the unit circle where t is the parameter. Together, these equations are called parametric equations. No, they're called a parametric a parametric representation of the curve. The notion of parametric equation has been generalized to surfaces, manifolds, and algebraic varieties of higher dimension, with the number of parameters being equal to the dimension of the manifold or variety, and the number of equations being equal to the dimension of the space in which the manifold or variety is considered. Okay. In Cartesian geometry, equations are used to describe geometric figures. Maybe I can get to this later on. For now, I need like simple. So I need this, and I think I might need this as well. So like, yeah, this is what I'm talking about. I'm usually not in situations where I have to do this kind of stuff. right? Usually I have the equation with me. Give me a second. I need to move my model. Okay. 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 Okay, cool. So this is what I need to look into right now, the algebra side of things. I think I need to look into polynomial equations. I'm not sure. And then I need to look into systems of linear equations and how to solve them. Did they explain how to solve? Because it just seems like... Oh, wait, no, it's not telling how to solve. It's the solving is here. There, it was just telling what kind of equation it was. And then here, they teach you how to solve it. Equations involving linear or simple rational functions of a single real-valued unknown, say x, such as so-and-so, can be solved using methods of elementary algebra. And then that takes us to a different thing. All right, fine. So I'll look into this on my own time. For now, we can carry on with the slope. Now, the slope is illustrated for y as so-and-so. Okay. Slope of a line in coordinate system from f of x equals so-and-so to f of x equals so-and-so. F of x, is that how we would say the slope of the line? Like, it says the slope illustrated for y. And here it says the slope of a line. F of x. Well, okay, it says f of x because we are calculating it for y, right? F of x means we are using the value of x. We are passing that into our function. Our function here is this equation. I'm guessing that's what it means. Now, that being said, let's pick any two lines here. Okay, let's pick this line. Can I pause this somehow? Oh shit, what did that open up? Okay, can I pause this somehow? My god, don't just... Holy shit. Okay. Right, let me pick a decent position. So -2 and +2, or -1 and +2. Let's try -1 and +2. So let's pick those 2 points, -1 and +2, and then we're going to use the change formula and do it in that way. Okay. So let's comment this out. Yesterday, by the way, we had at the beginning, when we got into calculus, we had looked into this thing. So we started learning about like limits, right? And then we looked into this formula, and I couldn't understand why the formula was returning y equals 0 divided by 0 until I actually did the calculation. So it returns 0 if x is 1. And the reason it returns 0 if x is 1 is because if you try to solve this, 1 to the power 2 is 1, and then you subtract that by 1 and you get 0. And then you go for the denominator, x is 1, 1 minus 1 is 0. So that's, the answer is basically 0 divided by 0, and you can't divide by 0. So the answer, that is why the answer is undefined. This didn't occur to me yesterday. I guess because I was just reading it and I hadn't like mentally tried to solve it. But yeah, we'll get back to this. For now, what did I say? One point was -1, the other point was +2. So I'm going to write some code here. Let's say P1 is equal to, what was it? P1 is equal to -1. No, hold on. P1. Our first point. Okay, yeah, so x is -1 and y was 0, I believe. And then P2 would be x is 0 and y is +2. Right now, if we are calculating the slope would be the change in y divided by the change in x, right? So that would be P1 minus P2. No, hold on. P1 dot x. How do we access the thing for a tuple? Is it like this? I think it's like this. Okay. So P1 1 minus P1, no, minus P2 1, I think. Yeah. And then we divide that by P1 x and minus P2 x. I think I did that right. I think so. Now, once we have that, we can print it out. This should be our slope, right? Now let's try doing this on paper real quick. Right, so we have P1 equals -1. Was it 0? Yeah, it was 0. Give me a second. Just a second. Okay, so it was 0, right? Okay, then P2 equals 0 on x but +2 on y, and then the slope is supposed to be we're talking about 0.1's x, no, 0.1's y minus 0.2's y. So that would be 0 minus 2 divided by 0.1's x minus 0.2's x. Wait, -1 minus 0 is going to be 0. No, it's going to be -1. -1 minus 0 is... Is it? I keep confusing this thing. Like when we start talking about negative numbers, I can't figure out if the calculation is supposed to go like in the opposite direction. Okay, hold up real quick. Here, let me just open up a Python interpreter so I'm not running a script each time. Give it a second. Okay, so -1 minus 1 gives us negative. So that means it goes in the opposite direction, right? It subtracts that same number. But then if we add it, then it goes in the forward direction. So like I'm trying to look at it from like a I'm trying to, because like, okay, we were given like, yo, Summer, welcome to the stream. Hello, how are you doing? We are learning math, dude. We are learning math today. I'm learning calculus because I never got a chance to learn calculus back in school. Funny enough, I also never got a chance to learn trigonometry. But I learned that once, like I learned it years after getting out of school. Once I got into game development, I started learning trigonometry and linear algebra and stuff like that. I never got a chance to get into calculus, but now that I'm doing deep learning, I kind of have a need for calculus. So yeah, I was just talking about, so like okay, back to what I was saying. We were, we were taught like, nah, you only do math? Cool. Nice. Walter White would be proud. Okay, what was I? Oh, so okay, we were taught rules of doing the calculation between positive and negative numbers. Stuff like, for example, two negatives make a positive, right? I'm trying not to look in that. I'm trying not to look at it from that perspective. I'm trying to not look at it from like the rules, but even though, like, I mean, I could just look at the rules and I would get the calculation right. But what I'm trying to look at it from, the perspective I'm trying to look at it from is, let's say we have -3, -2, -1, 0, 1, 2, 3, right? Now, to me, logically, it makes sense if we have -1 and we subtract 1 from that, we kind of go in the opposite direction, right? We're subtracting, keep in mind, we're subtracting +1 from it. And so it makes sense that we go in the opposite direction, right? Because we are taking 1 away from it. And likewise, if like, because we are subtracting, so it makes sense to me that we go in the opposite direction, we go backwards. And if we were adding, it makes sense that we go forwards. Like, that's the logic that I'm following here. So by that logic, did you see yesterday's rain or did you miss it again? I did see it. Holy shit, dude. That was some heavy rain, dude. That was some heavy rain. That was good. It was nice to see it. There was like crazy thunder as well, like crazy lightning and shit. It happened like, okay, they had said, I think they had said it would happen in like the morning or afternoon or something, but like it happened in the evening and night. It was so heavy. Like mom called dad and told him that there's like heavy rain. Just to, she let him know that like it's gonna be really heavy. So he even closed the shop early because he usually takes the bus to go to the shop and come back from the shop as well. So he closed the shop quickly and caught the last bus, and he managed to catch the last bus because if he didn't do that, then because of like the rain conditions, the buses would have stopped, and then he would have had to have someone come pick him up. So yeah, it was some crazy rain yesterday. Nice comfy weather. I can't believe you missed November 1st rain. It was boom. Yeah, I think I did. You know what's interesting about that? So I was sleeping, right? And I think I woke up at some point in the middle of that, and it was still like the sun hadn't gone down. Right? It was there was still like you could still see some sunlight even if the sun was, you know, close to going down. You could still kind of see sunlight coming through your windows and stuff. In between my sleep, when I woke up, I couldn't, like, it seemed dark outside. And that's when I was like, dude, I don't think it's evening time. Why is it dark outside? Could it be that it's raining? But like at that point I was sleepy, so I just went back to sleep. I didn't really give a shit about it too much. Give me a second. Let me hydrate. I've been talking for like 25 minutes and I haven't hydrated. Okay. How was Dad's birthday? It was good. It was good. As usual, we ordered from Pizza Hut, and we got drunk, and we had a good time. We watched a movie, and then I carried my party on all the way into the next day. It was fun. It was fun. I'm waiting now for New Year's, which holy shit, dude, that's coming. That's coming soon as well. We are like now we are like less than a month and a half away from New Year's. It's crazy, dude. 2023 is almost over. That's crazy. And so much has happened this year. It's insane to think about it. Okay, okay. So, uh what was I saying? So if we have -1, right, and we do -1 plus 2, because we are doing -1 plus 2, because it's an addition, to me, logically, it makes sense that the answer that we'll get is 1. Right? That's how I'm looking at it. Like I'm using plus as a positive direction and minus as a negative direction. So like, or I'm using addition as a positive direction and subtraction as a negative direction. You know what happened today? I finally finished The Big Bang Theory. Hell yeah, dude. Nice. Dude, I've been watching a bunch of stuff on Netflix. They've got some good stuff. Even like Hindi series. They've got some good stuff. Have you watched Kala Pani? That is, man, that was a series. Holy shit, that was good. That was good. There's only one season of it, and I don't know if they're gonna make another season, but like the way that they ended the first season, I'm satisfied with the ending. It wasn't exactly an ending, but like they definitely didn't leave it on like a major cliffhanger or something like that. Unlike Sacred Games, which Sacred Games is also a really nice series. I don't remember how many seasons they had. Either it was one very long season or 2 seasons, and then there was no third season, or there was it ended on a cliffhanger, and I didn't really like that because they didn't make another season after that. But like overall, the entire series itself was great. It's just the ending that I didn't really enjoy because they left it at a cliffhanger, and then there was just no season after that. This is one of the reasons why I don't watch incomplete series. I usually like to wait until a series is completely finished. I don't care much for watching something new very quickly. I don't need to do that. I'll wait until it has a whole bunch of seasons, or more preferably if the series is over, and then I can like binge watch all the episodes, because that's how I prefer to watch stuff. This is also one of the reasons why I prefer limited series on Netflix. Though, like, to be fair, even if a series is completely finished, there's still a decent chance that I'm not gonna watch it, because if a series is too long, I don't like committing to watching like an entire long series. Like, holy shit, dude! Like, imagine a series with like 6 seasons, and each episode is like, I don't know, 45 minutes or something, 30 to 45 minutes. That's really long. So like the series has to be really good if I'm gonna spend that much time watching. But yeah, usually I prefer limited series. Speaking of limited series, dude, there's some amazing ones on Netflix. If you are into watching horror movies, definitely check out Cabinet of Curiosities. Dude, dude, holy shit. That is so well made. It is amazing. It is just wow. That is a really nice series. The whole idea with that series is each episode is based on like a novel, I think. So like these stories have been written already, and these are like famous novels. They in their novel form they were really hit, and then they made like film adaptations of them, and man, they've done an amazing job. Holy shit. I don't remember how many episodes were there. Maybe 4 to 6 or something like that. But like each one of them, just wow, it is insane. Watch Korean drama. I really wouldn't mind it. The problem is, I don't want to read subtitles. I would prefer to watch something in its original language because the actors are able to capture the actors who are doing it like in their original language. They're able to capture the mood. They're able to capture so much more than what the voice actors who are doing the dubbing are able to capture. The problem is, if I don't understand the language and I want to watch it being voiced by the original actors, then I'm going to have to read subtitles, and I don't like reading subtitles. Okay, there's an ad playing, but Sama, I don't think you see an ad, so I'm going to carry on talking. Actually, no, I'll wait. 15 seconds. 15 seconds. Okay, welcome back. So, like I was saying, I prefer to watch, whether it's a series or a movie, I prefer to watch it in its original language because the actors who are doing it, like in the original language, they are able to capture the mood much, much better. Like, way, way better. They're able to just, like, dude, dubbing actors, like people who do the voiceovers and stuff, to their credit, they do the best that they can given the situation that they are in. But even so, they are not able to capture the mood that that they're not able to capture the mood of that movie. And I think part of the reason there might be because in different cultures and within different languages, they have different ways of expressing different types of messages. They have different ways of expressing certain types of emotions and different ways of delivering a message, different ways of getting a message across. And that just doesn't translate too well when you try to translate it to a different language, namely English. When you try to translate from, a very good example would be from Korean to English, the translation, you might maybe be able to get the translation one to one, maybe. I'm not entirely sure. But you definitely will not be able to capture the mood. You won't be able to capture the emotion that is conveyed. Like the way that somebody who is speaking in Korean would convey the emotion and the message, you won't be able to capture that no matter how much you try. I think it has, like, there's a lot of reasons for that, but that is one of the things that ruins it for me. The fact that they're not able to capture that emotion, they're not able to capture the mood that is being portrayed in that series in the original language that it's made in. And so that's why I don't like watching dubs. Yeah, you are acing this distracting me thing. It works. If I'm like passionate about something, I can just go on and on and on. Like, dude, yesterday, no, I think it was a week ago for Diwali. I had to go outside for like delivering orders and stuff, because like the entire family was like, you know, busy with the business. So I was also helping out with the business. And at the end of the day, I had some time before I had to pick mom and my brother and dad and all. So I went and picked up Mona and we went to the cafe. And we sat and chatted for a while, and then eventually we had to go, so we did our thing. And like I had to go pick up mom and everyone else. And that was done. But then we met up again the next day, and believe it or not, even the next day we had stuff to talk about. Like we just find topics that both of us are like passionate about and just start talking. Guess whose birthday is coming up? I don't know, man. You tell me whose birthday is coming up. Whose birthday is coming up in what, 9 days now? You tell me. You can eat cake. Hell yeah, dude. Which cake are you planning on getting? Okay, so like I was saying before about this thing, this so the way that I'm trying to imagine this, right, is if we are doing addition, then it goes in the positive direction. If we are doing subtraction, then we are going in a negative direction. I'll have to find a way to visualize what happens during multiplication and division, but for now I'm not going to do that. Chocolate cake, hell yeah, dude. Nice. I haven't had cake in like ages. Yeah, I haven't had. Well, I mean, I still have like stuff from the bakery occasionally. Yeah, you know, like that, the stuff that you get in like prepackaged, like raisin cakes and stuff like that. I'll have that once in a while. I'll have like cupcakes as well every now and then. That's good. Okay. Now, why was I doing this whole thing? Oh, I think I was doing it to do this thing. So 0 minus 2 would go in the opposite direction, meaning it would be negative 2. And then that is divided by, so negative 1 minus 0 should give us just negative 1 because you're not subtracting anything from it. Now, what would negative 2 divided by negative 1 be? Wait, yeah, what would, okay, let's, negative 2 divided by negative 1. That's 2. Okay. So that being said, our slope should be 2, right? If we are using these coordinates, then our slope should be 2. So we're going to try that out and see what result we get. Dude, why didn't you make cupcakes with the recipe of that AI thingy? Well, I forgot. Yeah, that's all I can say. I forgot. I do need to make something soon though, because my fried rice that I'd made ran out. Fortunately, I have chicken. Dude, have you ever tried chicken and turai? Holy shit, dude. It's a nice combo. It's a really nice. Actually, I think I've told you about it. I think I've told you about it. I made it previously as well. Man, that was good. Like have that with some rice. Holy shit. That is that was good. Recently, I think Swapan brought the he actually brought a bunch of other vegetables. So like I have a couple of options for stuff to make. I haven't made like flat beans a whole lot. I think I've made it like once, and I made like a gravy kind of thing. Such a dubby thing you forgot. True. Yep. That's definitely me. I probably forgot. Wait, no, you didn't. What is that? Turai or Torai, as like a lot of people say. I think you had said that you guys call it Torahi. I think. I think so. Because I remember me and you had spoken about Torai, and you had mentioned it's called Torahi. I think. But yeah, I'm just whatever. So you have turai, the vegetable. I like it by itself. I make that like by itself. I love the texture of it and the taste and all that. But I decided to mix it with chicken. And wow, dude. You throw in some potatoes as well, make a nice gravy kind of dish. Holy shit. They go so well together. It is just, man, dude, it is it is crazy. I don't remember what it was called. Was it called Chinese okra? Or was Chinese okra some other vegetable? Let me just Google this. In English, there was a different name for it. Let me just look this up. I think it might be Chinese okra. I think. I'm not sure. Like, I mean, I'm kind of seeing. But yeah, there's a bunch of vegetables that I can. Hold on. Turai in English. Turai vegetable is, yeah, it's Chinese. It's Chinese okra, apparently. Either way, dude, amazing. Give it a try. It is just wow. Definitely try it out. Right, now we got our answer, right? The slope is 2. What just happened? Okay, so we got our answer. The slope is 2. So we can go back to this and check. Oh, the music stopped at some point. I didn't notice. Okay, so we can go back. Where was it? Yeah, I think it was here. So -1 and +2. Hold on. 5x plus 2. 5x plus 2. How is it getting that equation? Because it said y equals mx plus b, but like how is it getting? How is it arriving at this equation? I don't think I've understood that. One can obtain the slope of the line by so and so by dividing the difference in the y coordinates by the difference in the x coordinates. One can obtain the slope of the line like so and so. Okay. Since the slope is positive, the direction of the line is increasing. Okay, so yeah, they had like a set of rules here, right? If the line is increasing, it goes up from left to right. The slope is positive, meaning m is greater than 0. Okay, so m's value is m is a positive number then. So in this case, that makes sense because my slope is going from like the bottom left to the top right. So it's going like in a increasing kind of direction. And then a line is decreasing if it goes down from left to right. The slope is negative, meaning m is less than 0. So like, I mean, if I just change the order of the operation here, then that would accomplish pretty much that. So if I do this and this, it should give, I think it should give -2. Let's see if it gives -2. What is this? Oh shit, dude. Hell yeah. You've got your emotes. Dude, I like that Twitch gives us these options for emotes, and it works, right? It's great because like they give you like color options as well. I think I think one that I had selected for mine was this one. And I picked the purple one. Eventually, something I want to try once I'm able to like set up stable diffusion models, I want to try generating the image using AI. I want to try generating like a small emote using AI, and I want to see what kind of result I'm able to get. That'll be interesting to try out. It doesn't necessarily have to be like Gen AI stuff. I think at this point in time, Microsoft is also planning on providing something. I think they already have something that you're able to use. You're either able to test out or directly start using it. I don't remember, but you need a live account for that. That's like the only requirement. I think, like, I don't know what the pricing situation is around that either. But yeah, there's going to be a whole lot of like Gen AI stuff. I still like the flying Dorito. You know what? Dude, we could make flying Dorito an emote. I could try AI generating a flying Dorito emote. Just like a Dorito with wings. So then that can be one emote, and like that can be a follower emote of mine, or I can make it a sub emote as well. That would be fun. Okay, so the answer came back here. The answer is +2. So that didn't do what I thought it did. Was I looking at it wrong? Because like, okay, let's look at it decreasing. If we are looking at it decreasing, we would have to change this a little bit. So let's switch it back to its previous configuration. But here, let's make it -2. So it's not going from bottom left to top right. It's going to go from bottom left to bottom right, or mid left to bottom right. So let's see what comes up here. You did try to make it appear on screen once upon a time. True. I might actually introduce that again. Oh, okay. So there it is. So this is not going from right to left, is it? If it goes from left to right. Oh, it said here if it goes up from left to right, but then if it goes down from left to right, then it's this. Okay. All right. So the left to right doesn't make a difference. It's the up or down that makes a difference. Well, I guess, okay, no, left to right does make a difference. Well, no, left to right doesn't make a difference. Oh, also, yeah, you're right. I did try to make it appear on screen once upon a time. I might introduce that again with my current VTubing app, because I've been making I've been making progress with my VTubing app. In the past few streams, if you look at the older VODs, you'll see I managed to get body tracking working. And so I'm now able to capture like body landmarks. Like I have a webcam set up that like it captures like my frames, like that it's recording me basically and capturing frames, and then in those frames I'm able to detect landmark positions that tell me where my shoulders are, where my elbows are, where my wrists are, where my head is, basically those kinds of landmarks. It tells me where they are, and then I can send that over into my VTubing application, and I can, if I want to, I can control my VTubing avatar with that. One of these days I wanna add that. My phone weather app says it will rain on Monday. Nice, dude. Hell yeah. Yeah, dude. You know what I was thinking about, like when you spoke about rain? Parathas and any kind of like hot drink. Well, I mean, with mom and dad, it's more famous that they have chai and paratha. So like paratha with milk tea. But like it can be any hot drink. It can be coffee as well. It can be. I mean, in my case, it's not going to be. Dude, I haven't had parathas in like ages. Like ages. I'm not even kidding. Because like mom used to make. Mom still makes once in a while, but like I cook my own food. So like unless it's something that I'm willing to make. Oh yes, pakoras and bhajias and stuff. I could try making that. Yes, that's a good idea. Dude, I should try making that. I can make like onion pakoras. I could make onion pakoras. I could make palak pakoras, spinach pakoras. I'll see whatever like vegetables we have. I think that would be fun. Did they give a time for when it's going to be raining? Because like I could make it in like the evening, or I could make it in the afternoon as well. I'll have to go and get chickpea flour, besan. I'll see if I can get like a sealed bag, and then it'll be like for a one-time use kind of thing. Because like for bhajias and pakoras and stuff, you can't get any better than besan. Like besan just has like a different thing going on. Oh, is the music still going? Let me just make sure. I don't think this music has been going at all. Ever since I tried to resume the music, the thing just got stuck. You've got to be kidding me. I assumed it would fix itself, but it didn't do that. And now there's an ad playing, so let's wait for this ad to finish. Yo, you know those big green chilies? Those pakoras are yum. Yeah. Mirchi bhajia, basically chili bhajia. It's kind of interesting how they are made. So like those are spicy as well because it's chili. So like it's gonna have a certain level of spice. But the great thing with those chilies is the great thing with those chilies is like in terms of like how they make the bhajia, what they do is they empty out the core and they keep it to the side because like the seeds are what contain the actual spice in the chili. It's not the skin. The skin is like by itself, it's not really that spicy. The seeds contain the main spice, right? So they remove the seeds and the core and they keep it aside, and then they mix all sorts of like masala and stuff, with those seeds, and then that masala becomes the stuffing for the chili. And once they're done stuffing it, then they dip that into batter, which is, in the case of Indian and I think even in Pakistani cooking, it's usually a besan based batter. So they dip it in that and then they just fry it. Also, Indians love bread pakora. That is true. Yes, they do. I didn't know that they actually use some kind of like potato stuffing in their bread pakoras. Because the one that mom used to make, like, I mean, she would make like a mix of stuff, but I didn't know what the official recipe was. To be fair, I don't think in this day and age, a lot of us give a shit about. I myself don't give a shit about like what the original recipe is. I don't even give a shit about calling a dish by a certain name, because most of the time, like, I'll just mix whatever ingredients I see fit. And I don't like giving it a certain name, because then it's like, oh, okay, you have to follow this recipe and only then it's going to be the... Nah, I'll make whatever I want. Speaking of making whatever I want, one of these days, I want to make chicken tikka. Or butter chicken. I haven't made butter chicken in like a long time. There's, with various recipes, you have like different things that you have to do. For example, with like butter chicken, you kind of want to use tandoori chicken, or any kind of like, even if it's chicken tikka, you kind of want chicken that has like that has charring on it. Chicken that has been cooked with fire, you kind of want that kind of chicken. So it has like a very different kind of flavor in it. Not only that, in order to introduce like a smoky flavor into it, towards the end, once the dish is ready, you kind of have to do this thing where you take like a bowl, a katori, and in that you put some hot charcoal, and then you drop some oil in there. Oil, or I think ghee might work as well. I'm not sure, but oil. Yeah, you can drop some oil in there. And then you cover that whole thing. So you basically place this katori in your dish where your butter chicken is, but you don't drop the charcoal in there. You just place the katori in there by putting like some kind of space there. And then you cover the entire dish as the smoke is coming out. You cover the entire dish completely so the smoke doesn't escape. And then after a few minutes, I think, you can like take the lid off, and your butter chicken is going to have, or whatever dish you're making, it's going to have a nice like smoky flavor to it. And dude, that is just, wow, that is amazing. But yeah, I don't usually do chicken dishes that require me to like fry the chicken or bake the chicken. It's just so much easier to throw the entire thing into a curry. It's so much faster. Like, dude, it is so much faster. Usually, like, I don't go for like special preparation when I'm making my food. Like the simplest chicken curry I'll mix whatever whatever dishes or whatever ingredients I have. And even without doing like special tricks and stuff, I'm still able to make like a decent chicken curry or even a veg curry. Surprise your family with pakoras and send me a pic. I might cook. That's a good idea. I was thinking like, yeah, okay, maybe I can make something. You mentioned 10:30 a.m. to 11:30 a.m. Okay, I mean, you know what? That would be fun. Cause like, okay, the forecast says 10:30 to 11:30 a.m. but it could be later. You never know. If it's later, it's better, because that way, by the time afternoon rolls around, of course, everyone is going to be having their lunch, right? So even then even dad can get to have it, because like he's going to be outside and he'll be home by afternoon time. Actually, Swapan will also be outside. and he'll come by afternoon time. Yeah, I might make it. I might make it for lunch. They can heat it up in like the microwave. They unlike me, they do use the microwave, so they can just heat the thing up. It doesn't have to be like fresh hot. Though fresh hot would be super nice. But like, it is what it is. Give me a second. Okay, so getting back to this. So I found out how I can find if a line is increasing or decreasing. And then if a line is horizontal, the slope is 0, so it's a constant. And if the line is vertical, then it's undefined. And that makes sense because we would be dividing by 0. My mommy once invented a pakora, and it was yum, spaghetti pakora with chicken and vegetables. Dude, that sounds good. Yeah, it's kind of interesting. Like when you don't give a shit about like official recipes and you just start mixing shit up, you can come up with some really amazing stuff. Some like really amazing stuff. Like what your mommy made is a very good example, right? Spaghetti pakora with chicken and vegetables. Like that's perfect. That's adding spaghetti to that kind of thing. And not to mention the chicken and vegetables and all that stuff. All she had to do then was like put some extra masala in there, and like you get like a decent kind of like pakora or bhajia or whatever. Something I've never tried is making. I could try a similar thing with pasta. Actually, let me see though. Because like I don't have to do specifically. Earlier my plan was onion and spinach pakoras, right? But something else I could also do is... Actually, no. That might get a little complicated. So like, okay, if I mix everything up with besan, the whole idea with making a besan kind of thing, the whole idea with involving besan into it is that it's much better than using all-purpose flour or regular flour, because like the taste is also very different. The way that it cooks is also very different. I can make the batter and I can just put all the stuffing into that batter, and then I can cook the batter directly, and I get like decent bhajia out of that. But like if I was doing like, I don't know, all-purpose flour or regular flour or something, I would have to make sure that the flour is only on the outside, it's not on the inside, because otherwise it gets like all... There's like all sorts of weird things I would have to worry about, like in terms of whether it's cooked or not and all that kind of bullshit. I could try baking the thing, but I don't want to bake it. Like frying the thing is just so much more simpler. It's so much more quicker. Maybe not the healthiest, but like it's a one-time thing, so I don't need to worry about that. Yeah, it's a one-time thing. It's not like we have rain all year round in Bahrain. So like when it comes around, let's enjoy it. I'm gonna be going out tomorrow with JD and Mona, and where we are going, I don't think they have like an outdoors kind of setup. But if they do, maybe we can enjoy rain, or at least the weather, if it does happen to rain. I say besan pakoras are too heavy. Now using cornstarch will make it lighter and crispy. I did not think about cornstarch. That's a good idea. But yeah, you're right. Besan pakoras are definitely more heavier. Though, in terms of... Because like besan is chickpeas. So the way I'm seeing it, there's like a whole lot of protein going on there. Besan is chickpea flour. So it's just ground up chickpeas. So like there's a whole lot of protein going on there. So I guess that's a plus side. The only downside there is like, first of all, like you said, it's heavy. Also, like, it's deep fried, so it's like super oily and like unhealthy. But like once in a while, it's not a problem. Yeah, it's fine. It's fine. I'll get a bag of besan. Tell them I say hi. I'll do that. Hell yeah. Hell yeah. Shit, I might make a video. I might make a video and then send you. I'll make a video of them saying hi to you, and then send it to you. Maybe I won't send it at that time because like I won't have internet at that time in the phone that I have my SIM card in. But like once I get home, then I'll be able to send it to you. Okay. Carrying on with this. So we are done with this, right? Now I need to. How do I check if I got the thing right? How do I check if I got this right? F of x equals, let's say, negative 9x plus 2. I'm not sure how it's getting this formula. Interesting to see it that way. Protein. Yeah, because like, that's the thing, right? Besan, that's another reason why I think besan is better than using flour. I don't know if flour contains protein, so I can't speak much on that, but like I know for sure that chickpeas are a good source of protein. So like chickpea flour it's literally just chickpea powder. So like chickpeas have been ground up. And so that's like a whole lot of protein. All you're doing is mixing water and a bunch of other like whatever spices you want to mix, and then whatever vegetables and stuff you want to add, and then that's your batter. So you can then, maybe you might need to add, depending on like what kind of consistency you're going for, maybe you might need to add some other kind of flour. So that could be regular flour, all-purpose flour, or cornstarch. That could be another good addition to it. But yeah, if you need something to like glue everything together, maybe you might need some flour. I'll have to see, like, let me mix some water into it and see what kind of consistency I get out of it. And yeah, let's see what happens there. I've never tried, I have tried like cutlets. Basically, I've tried making cutlets before. I'm usually not a fan of the kinds of dishes where I have to like prepare batter and then prepare the stuffing and then mix the stuffing with the batter, or coat the stuffing in batter and then fry the thing. Usually what I'll do, because I'm so lazy, what I'll do is I'll just cook the thing and have it with something else. Like if it's a stuffing, I would much rather just like make a sandwich out of it instead of going through the trouble of making fucking bhajias and pakoras and all that stuff. That's why I leave it for like dude, these things are good. These things are good if somebody else is making it for you. But like if you're going to be making it yourself, it's way too much work to do each time. Which is why you see this kind of stuff being sold in like shops and like roadsides and stuff in India and Pakistan. It's a lot easier to just have someone else cook it up for you, and then you go and buy it from them for cheap, rather than making it at home. Give me a second, let me hydrate. But dude, whatever you're gonna make at home, you can't get any better than that. Like this even the street food stuff, it's not gonna get any better than home cooked bhajias and pakoras and stuff. At least for me. Maybe it's because I'm used to eating home food. Okay, so I need to figure out where this formula came from. Slope illustrated for y equals 3 divided by 2, 3 divided by 2 multiplied by x minus 1. And here the slope of a line in coordinate system. How did they get 3? Okay, where is 3? First run 2, then rise 3. Okay, first rise 3, then run 2. Okay, so it's counting the number of steps that it's taking, but like, what does this have to do? Home food is clean and you know what's in it. That's very true. That is definitely very true. Yeah, I've noticed this with like, cause like I stopped eating restaurant food. I haven't eaten it in like close to a decade. The only restaurant that I eat from, like the only thing that would qualify in this scenario for, you know, me eating restaurant food is when I eat pizza from select few places, and it's literally only pizza that I eat, and that is only a couple times a year, like a handful of times a year. So the majority of the food that I'm eating is like home cooked. And so yeah, I know what's in it because I'm the one that's making it usually. Unless it's like bakery items, which once in a while I'll have that as well. Maybe like I don't know. There's different types of stuff. Like, you know, you get like cheese puffs and za'atar puffs and chicken puff. Chicken puff is like a chicken puff and veg puff. They're like classics. Back in the day, I used to eat them like a lot. I hated the fact that like puffs, they're super messy to eat because they're so flaky. Like each time you take a bite, you're gonna drop something somewhere. If you don't have a plate beneath you, you're definitely dropping something somewhere, because that's just how it is. The way that its shell is, it's just very, very flaky. It drops stuff each time you take a bite. Okay. F into x plus 2. How exactly are they arriving at this equation? Is this described somewhere else? I'm curious as to how they arrived at this equation. Because like it's describing here exactly what we had previously, right? Oh, this is interesting. So they used tan here to get the slope. I never thought about it in that way. But when I go to Pakistan, I want all the dirty golgappas and pakoras from the roadside. It's fun. I mean, look, the food is tasty. Like, I can definitely agree with that. It's definitely also very, very, very dirty. Like roadside food, roadside sellers, the hygiene is just, it is, what's the word? It is non-existent in those places. But the food is tasty. The food is really tasty. In fact, not just roadside sellers, even some restaurants, the hygiene is just horrible. The food is good though. The food is tasty. And like a lot of the people that live there, to them it's just it's what's normal for them. So like it doesn't bother them that much. But like for people like us who don't live there, if we go there, we can still eat the food, but like we have to be really careful with what we eat, because our immune systems are not they're not used to those kinds of germs. The people who live there, their immune systems over the years, they've like adapted to those kinds of germs. So even if they go out and eat street food like the entire day, they still won't get sick. But people like us, because we live in a different country and we are used to a different kind of, like, our immune systems are also used to fighting germs, but different types of germs, not the kinds of germs that they have there. So like we can get sick very, very easily if we go there and just comfortably start eating all the street food. Give me a second. For some reason, I'm getting super thirsty. Okay, so okay, back to this. So, also you said unhygienic. I know. That's the daredevil and fun part. Well, having made that mistake in the past myself, it's not fun for me, but like, you enjoy. The last time I went, believe it or not, even though I didn't eat street food, like I had from select few places and not all that much. I mainly stuck with home cooked food. I still managed to get sick. Like I didn't even go out. I was at home when I was there. I didn't even go out. I was at home and I still managed to get sick. The reason was, and this was like before COVID, so this was a good like five or so years ago. The reason was because just the change in atmosphere, the change in weather. It's again like my immune system is not used to those. It's not used to that atmosphere. It's not used to those kinds of germs. Whatever is going on there, it's not used to that, right? It's not like there's something horrible going on there. It's just that my immune system is used to another country's weather and another country's atmosphere and whatever germs are going on in like this country where we live, right? But like there's a different situation going on. So like it's super easy for me to get sick. Fortunately, it wasn't something too bad. There was definitely a fever there. So like I was definitely sick, and for the sake of getting better quickly, for the first time in years, I had to take a Panadol, because like I avoid medicines unless I absolutely need to. So like even if I'm sick, I'll still not have like a Panadol or something. Usually I'll just let it run its course. If I get sick like once a year, if that at all. And usually when I get sick, it's because of the change in weather. Just like a lot of other people, it's not something specific to me. A lot of other people also, they get sick during like a sudden change in weather. So when there's a change in weather, I'm kind of expecting it to happen. Either it'll be from summer to winter or from winter to summer. Did I say that right? Either it'll be from summer to winter or from winter to summer. During one of the two, it happens. And if I feel it coming on, usually what I'll do is I'll go and cook some chicken sweet corn soup for myself, because I know I'm going to be sick and I'm not going to be able to cook. So I make a nice big batch that I can then just eat for the next couple of days. And usually it just goes away in like 2 days or something, maybe 3 days. 3 is also a stretch. Like by the second day, I'm kind of feeling better. I think the last time I had it, which was this year, I believe. I think it was this year. Or at the end of last year, I don't remember. The last time that I had it, I think it lasted for 3 days, maybe. That wasn't fun. Because like I also had like a headache kind of thing going on. So there was a little bit like extra going on there. Not just like a fever. But yeah, I mean, it eventually went away. Yep, you're not used to that atmosphere. Your family did go to India after years. Well, it was mainly me that got sick, no one else. Though, I mean, it was just me, mom, and Swapan who had gone. At least like the last time that we went. And like since then, I believe mom has gone once before. I think. I think. I don't remember. No, maybe not. Maybe not. Or maybe she did. I'm not sure. This stream is just us talking. That's okay. I kind of like that, actually. I mean, we are in the just chatting category. So like, you know, I'm not complaining. In fact, at some point, so I was talking about like, because you had mentioned earlier, right, that I was trying to add emotes on the screen. I kind of want to attempt that again with my current VTuber program that I'm building. And I want to also try and add chat, but like in the app. Because like I can add chat right now on the screen if I wanted, but like it would have to be through another source. I want to create the source myself, like in my VTubing app. I want to try doing that myself. I'll have to see how that goes though, because I don't know what the situation is going to be in terms of, because like if I'm generating text, if I'm doing a bunch of text operations, there's going to be garbage collection, and that's going to be a problem. Give me a second. Okay. So yeah, I wanna try adding a bunch of features. When I was young, I used to get out of the airport in Pakistan, sit on a suitcase, and the first thing I would, oh damn, damn, that's crazy. Yeah, it's insane. Like I remember even when I was young, I've gotten sick like quite a bit. This one time we had gone to my dad's side of the family, and this was like when I was a kid. Like I was a kid. I was small. Well, I was a teen, I think. No, I wasn't a teen. I was a kid. I was like younger than teen. And we had gone for somebody's we had gone for like a family member's marriage. And so there was a whole lot of like moving around going on. You know how marriages are in like India and Pakistan, and they have like a whole bunch of like fucking ceremonies they do, and they're calling people here and there. There's gatherings, and then there's parties in multiple places. There's gatherings before the marriage, there's gatherings during the marriage, and then there's gatherings after the marriage as well. So like there was a whole bunch of like moving around going on, and during the marriage, like when the on the day of like the actual marriage, um in that area they had like a food, because like during marriage they have like food set up, right, so people can eat. And at the time, because of how young I was, I didn't realize that I shouldn't go and just start eating everything here and there, because the hygiene there is, like we've already discussed before, the hygiene there is just shit. So if you are coming from a different country and your immune system is not used to the germs there, you are definitely going to get sick, especially if you eat like fucking marriage food, where the hygiene is even, it's probably just as bad as the stall, the street food, the street vendors. So like I ate, and I was fine on that day, but the next day I got like crazy sick. It wasn't just like a fever. I got diarrhea, and then I got dehydrated. That's not a good combo. And on top of that, I had a fever. So it was like crazy sickness going on. Like they had to go and get they have this thing called ORS, oral rehydration solution. It rehydrates your body, but it gives you a little more than just what water gives you. And it's really helpful in situations where you're really dehydrated. And if you've been like either if you've been puking a lot, or you've had a lot of diarrhea, then you're losing a lot of water from your body. So if you end up in a situation where you're like super dehydrated, then you kind of have to take those kinds of measures, because I think at a certain point, just drinking water doesn't do it for you anymore, or you're just not in a situation where you're able to drink water constantly. Because at that time, because of how sick I was just sleeping all day, and the only time I would get up is to go to the toilet or to eat, and then I would go back to sleep again. And I was also missing meals because of how sick I was. And so they had to give me ORS. And then like eventually the thing goes away after some time. It's just like your body is not used to it, and because you're a kid at the time, your immune system is even weaker at that point, right? So like any sickness that hits you, it kind of hits you really hard. So yeah, that wasn't fun. But now when if I do go there and I get sick, it's not usually that heavy. Yeah, even now when I go to Pakistan, I have to be careful on what I eat, how much I eat. Yeah, at this point in time, if I did go, I don't think I'm gonna go. Like, to be honest, but like if I did go, I would probably just be cooking my own food there, which is gonna be interesting, because like with my own food, I'm kind of like really well. I mean, my situation. So like I'm very particular because of my issue that I have. I'm very particular about what I eat, how I cook the food, and like in what situations I'm willing to eat it and stuff like that. So yeah, it would be kind of interesting. I don't plan on going. I don't plan on going anytime soon. But like the last time that we went, I didn't realize it at that time. But the last time that we went was actually when I was discovering that my issue was getting progressively worse. because after that I started to notice more and more and more things. Things that like I was okay with it at the time, but then I discovered that I'm not okay with it, and so then now I wouldn't eat those things under those circumstances. Actually, I wanted to go with mom to Pakistan in February, but because of my leg, I couldn't, and I was so excited. That sucks. By the way, dude, speaking of your, how is your leg? Like, what's the situation with that? You had told me that you had an appointment with your doctor, but this was like weeks ago. Maybe a couple months ago. I don't remember much after that because like you said that there was, I think they'd taken another scan. But yeah, let me know like what's the situation with the leg. Okay, so I'm still confused as to how they got this f of x equals -12 so and so so and so. Yeah, it's better just wait. That's all they've said. Just wait. I mean, that makes sense. I mean, they can't really say anything more than that. They just have to, you just have to wait. So like it makes sense that they told you to wait. Okay, there's an ad playing, so I'm gonna take this opportunity to hydrate. Oh, okay, hold on. Welcome back. Also, yeah, I just saw your continuation of the message. You accidentally hit enter. Okay, so you were saying, yeah, it's better just waiting for my next surgery, hopefully next month. Oh, okay. All right. That makes sense. Wait, why am I saying that makes sense? I'm so used to saying that makes sense. I'm saying that makes sense as if I know that you're going to have another surgery. But yeah, you have to have another surgery? Okay. Wait, no, you did say that you had to have. Wait, no, yeah, this was. But no, this was a while back that you had said that you had to have another. I think that's why I forgot about the next surgery part. But yeah, I think you did say this was a while back that you had gone and you had to like schedule another surgery. Okay, okay. So I'm still confused as to what's going on here, but I'm not going to dig into this too much. I need to know if I'm calculating the slope right. Then the slope of the line is so and so, so and so, so and so. Yeah, okay. So apparently I'm calculating the slope right. Okay, you said yep to remove. Oh, it's to remove the rod and screws. Okay, I didn't know that that was a thing. Like they actually remove the rod and screws as well. I thought it just stays there to hold it in place. Though I think it depends on the situation. I think that there might be some situations where they leave it in place and some situations where they are able to remove it, so they remove it. I think so. I don't know. Okay. Um You won't be a robot anymore? I mean, good. You know what you could do? You could cosplay a robot. And you could, it could be like an inside joke that, oh, I previously had a rod and screws inside me, so now I'm cosplaying a robot. Funny thing is, I don't think a whole lot of people would get the joke other than people who know that you had a rod and screws inside. Okay, if y is a linear function of x, then the coefficient of x is the slope of the line created by plotting the function. Therefore, if the equation of the line is given in the form so-and-so, then m is the slope. This form of a line's equation is called the slope-intercept because b can be intercepted. No, b can be interpreted as the y-intercept of the line. That is, the y-coordinate where the line intersects the y-axis. How do you calculate? Okay, so the y-intercept has come up previously as well. I think it had come up when I was learning linear regression. The y-intercept. So this is where it intercepts the y-axis, which if the line is like infinite, eventually it's going to intercept the y-axis. What are we calculating here? B is interpreted as the y-coordinate where the line intersects the y-axis. The y-coordinate where the line intersects. So we are calculating when this intercepts the y-axis, what is the y value? That is called the y-intercept. Okay. In analytic geometry, using the common convention that the horizontal axis represents a variable x and the vertical axis represents a variable y, a y-intercept or vertical intercept is a point where the graph of a function or relation intersects the y-axis of the coordinate system. As such, these points satisfy x equals 0. Oh, that makes sense because it's when it intercepts the y-axis, x is 0. Y could be anything, but x is 0. That makes sense. Using equations, if the curve in question is given as y equals f of x, the y coordinate and the y-intercept is found by calculating f of 0. Oh wow, that's clever. Because we're talking about f of x, so to find the y-intercept, we find the value of f0. Hell yeah. Yep, okay. Functions which are undefined at x equals 0 have no y-intercept. If the function is linear and is expressed in slope-intercept form as so and so, the constant term a is the y-coordinate of the y-intercept. Okay, I didn't get that, but like I'm gonna move on from that. Okay, multiple y-intercepts, x-intercepts. Analogously, an x-intercept is a point where the graph of a function or relation intersects the y-axis, which in that case, I guess y would be 0. Wait, did I say y-axis earlier? It intersects the x-axis. And yeah, at that point, y would be 0. As such, these points satisfy y equals 0. The zeros or roots of such a function or relation are the x-coordinates of these x-intercepts. The zeros or roots of such a function or relation are the x-coordinates of these x-intercepts. Unlike y-intercepts, functions of the form y equals f of x may contain multiple x-intercepts. The x-intercept, oh, they may contain multiple x-intercepts. Okay. The x-intercepts of functions, if any exist, are often more difficult to locate than the y-intercept. Okay. They're often more. Oh, the x-intercepts of functions, if any exist, are often difficult to locate than the y-intercept, as finding the y-intercept involves simply evaluating the function at x equals 0. Okay. The notion may be extended for three-dimensional space and higher dimensions as well as for other coordinate axes, possibly with other names. For example, one may speak of the I-intercept of the current voltage characteristic of, say, a diode. I never thought about that. Okay. Oh, okay, yeah, I had a doubt that this is leading to linear regression. Cool, cool. So we'll get to this later on. Real quick. So, okay, hopefully after this I should be able to do like simple linear regression, which is kind of funny because like I started learning about linear regression when I started learning machine learning. But each time I went deeper into it, I would get stuck at the slope part because I did not understand what a slope was. Like I knew what a slope is practically, but I never actually understood what it is mathematically and how it is represented mathematically. And so it was always like a confusion for me as to like what is going on here. And like I would see this all the time, like this equation, and again I didn't get it. Okay, so if this is the function, if this is the wait, this is a y, this is the slope of y. Okay, what does linear regression tell us? Where's the formula for it? Formulation. Okay. Given a data set of n statistical units, a linear regression model assumes that the relationship between the dependent variable y and the vector of regressors x is linear. Okay. This relationship, the word linear keeps popping up, so I need to read up on linear function to properly, because I kind of get what it means in terms of like I have somewhat of an idea of what it means when it's linear. It's kind of like, okay, they both kind of like increase at the same, I don't even know how to say it because I don't know how to describe it, but I'm able to like imagine it. Like they both have like a linear relationship. So like when they increase in a certain way, or when one increases, then the other one increases in the same way. Not necessarily with the same amount, but like, see, I'm okay. I'm not. Let's. I'll once I'm able to come up with the words later on, then I'll describe it. For now, I'm not going to attempt it because it's probably going to turn into bullshit and it's not going to make sense. So I'm going to read up on this later on. Okay. 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 Where was it? Was it in... I can't remember where exactly it was that I had seen it. I'd seen it being used somewhere here. I'm sure I'll find it eventually if I look hard enough, but like for the time being, because like linear regression has it has a lot more than just that one algorithm to look at. There's like a lot going on there. And I believe you're also not limited to just one, well, two dimensions. You can actually do this in multiple multiple dimensions. You may not necessarily be able to visualize all those dimensions, but you can actually do it in multiple dimensions. If I'm not mistaken, I need to try it out. I need to test it out and see. I'll try first with 2 dimensions so I can at least plot it, then 3 dimensions, which I can still plot it, but then I'll take it into higher dimensions with like more variables and stuff. But yeah, dude, this is cool. Finally, I'm moving forward with well, not just calculus, but yeah, I'm moving forward with calculus and with linear regression, which is what I had started learning machine learning, or which is what I had started with when I was learning machine learning. Now I'm learning deep learning. So like I just let go of linear regression, and then when I started learning deep learning, suddenly linear regression came back. Okay, if y is a linear function, so I need to, this is linear function, right? Okay, so I'm going to need to read this later on as well. I don't think the music is still going. I've been super distracted. I didn't even realize. Okay. If the slope m of a line and a point, so and so, of a line and a point on the line are both known, then the equation of the line can be found using the point slope formula. The slope of a line can be defined by the linear equation so and so, and is negative a divided by b. Wait, what? The slope of the line defined by, oh, the slope of the line defined by this linear equation is that. Okay. Two lines are parallel if and only if. I don't think I need to read this for now. But yeah, I think we can move on from the slope thing. I think for now we can move on from slope and we can carry on with this. So I did this. I'm still not entirely sure what this is for, but like I tested this out. You know what, we can read it a little bit. I'm not done reading up on limit. I literally just started reading up on limits yesterday during yesterday's stream. So I'm still like very early on in it. Wait, what comes like at lower? There's still more to go, right? Okay, okay, good. So they're giving like examples and stuff. Okay. Right. So we can read this again. What is limit? Basically, the meaning of limit in mathematics is the same as the meaning of limit in the real world. Limit means boundary. What does it mean? Just as a reminder, in the function f of x equals 2x plus 3, x is called the domain and 2x plus 3 is called the codomain. Oh, the x that's being passed into f is the codomain. Okay, no, is the domain. And then the other part is the codomain. Now, in the concept of limit, we limit the value of x, which is the domain, to approach a value. Let's call it the value of a. Why just approach? Why don't we just write x equals a? This is because in some math and physics problems, sometimes we cannot substitute the value of a into the variable x. For some reason, sometimes we can only calculate the value of a function. For some reason, sometimes we can only calculate the value of a function whose x value is close to the value of a. What's an example? Try to solve the following questions. What is the value of y when x equals 1? Okay, so we came across this yesterday, and yesterday I couldn't understand why it was saying if you calculate it correctly. Wait, did they mention? Oh, they did mention x equals 1. I don't think I noticed that yesterday. Or maybe I did and just didn't take it into account. I don't remember. But yeah, I wasn't able to figure out how we were getting y equals 0 divided by 0 because I hadn't thought about the calculation practically. Like, I wasn't thinking that, hey, if x equals 1, x to the power 2 is 1, and then 1 minus 1 is 0. So the what's the top part called? The denominator? Or the numerator? I think it's called the numerator, not the denominator. Hold on. Let me just Google that, because I haven't used this term in like ages. Numerator and denominator. Okay. So the numerator would then be 0, right? And then you look at the denominator, it's again x minus 1, so 1 minus 1 is 0. That is why you would be getting undefined, but that is why the result would be undefined, because you cannot find an answer to that. You cannot divide something by 0. I don't think the answer would even be 0. It's just undefined because, well, you can't divide anything by 0. So if you try doing it, it's going to throw an error. Well, this is where the concept of limits works. We can't calculate the value of y when x equals 1, but we can calculate the value of y when x approaches 1. The word approach here means the value of x is very close to 1. It can be interpreted that the value of x is approaching 1, of x approaching 1 is equal to 0.99999 or 1.00000 and so on 1. Okay, so like a tiny bit below or a tiny bit above. Both values are so close to 1 that they represent the value of y when x is equal to 1. Okay. In the graph above, we can still see the value of x. No, in the graph above, we can still see the value of y at x equals 1. Okay. Because that value is the limit value, namely the limit value of y when x approaches 1. The value of y equals 2 is not the exact value of x equals 1. It's not the exact value when x equals 1. When x equals 1, the value of y is still undefined, but we can use the limit value. Oh, okay. So you don't use the exact like 2. You do like 2.0001, or you do 1.99999 something. We cannot say that the value of y equals 2 when x equals 1. we cannot say that the value of y equals 2 when x equals 1, because actually the value of y is undefined when x equals 1. However, we know that when the value of x is very close to 1, then the value of y is very close to 2. To express this, mathematicians use the concept of limit. So the above statement can be expressed as the limit of y, the limit value of y as x approaches 1 is equal to 2. Just a second, guys. Just a second, guys. Okay. Okay, so right. So the limit of y as x approaches 1 is equal to 2. You can write this statement as follows. The limit of y as x approaches 1 equals so and so. Is that how you're meant to calculate the limit? Like, is that the actual limit equation? Lim stands for limit, and x1 means the value of x is close to 1, so as x is approaching 1. Here's the general form of the limit concept. Limit as x approaches a wait, no, the limit of f of x as x approaches a is equal to k. Really? So f of x, that's how okay, the above equation means the limit of f of x as x approaches the value of a is k. K here can be a constant or a polynomial. I don't know what a polynomial is, so I guess I'll Google that later on. There's a condition. There's a condition that the limit f of x when x equals a is equal to k. That is the left limit. Wait, no. There is a condition that the limit f of x when x equals a is equal to k. Oh, that's a condition. That is like what's being described here, right? The limit of f of x when x is equal to a would be k. But no, I mean it says x as x approaches k. The left limit and the right limit must be the same. What is the left limit? And what is the right limit? The left hand limit is the value of y as x approaches a from the left. Hold on. I need to read this properly. Okay. The left-hand limit. So, okay, by the way, this, what I was reading here, this is saying when x is equal to a is, there is a condition that the limit f of x when x equals a is equal to k. That is, the left limit and the right limit must be the same. So the left-hand limit is the value of y as x approaches a from the left. For example, a equals 0. So left means like lower than it, right? And right means higher than it, I'm assuming. Then the left limit is the value of y f of x when x approaches 1 from the left, i.e. that. Okay, yeah, so the left limit is like below and the right limit is above, I'm assuming. The right hand limit is the value of y as x approaches a from the right. In the example above, the right limit is the value of y when x approaches 1 from the right, i.e. y equals 2 point something 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 1. Okay. While the left limit is the value of y when x approaches 1 from the left. Okay. Maybe it'll be easier to understand if we look at the graph directly. Take a look at the following graph. Okay. So that is A. Okay. All right. Okay. So what are we looking at here? I think I need to be able to like picture this. Yeah, I think I need to be able to picture this. I need to be able to picture this. So, okay. Oh, wait. Does it say y here? This just occurred to me randomly. It's nothing to do with like the other stuff we were just reading. But it just occurred to me. I was asking why does it say f of x like here? Is it because like it's the limit of a function? Is that what we are saying? Is that how it's meant to be said? It's the limit of a function? Because like then the function could be anything, right? It could be whatever algorithm, whatever equation we choose to put within the function. And then we are basically calculating the limit of that function as x approaches a certain variable. I think so. Okay. Okay. But yeah, I need to. Fine. Maybe I'll look at this later on. I don't fully understand what's going on here. Like why did the thing split up? But maybe I'm gonna have to just like try doing the calculation on paper, because like maybe they're trying to show something that happens within the equation. They're trying to like visualize this, but like I'm not able to visualize it because I don't fully understand what happened in the equation either. Okay. Why is limit important? The concept of limit is used in derivatives and integrals that utilize the concept of small parts. Okay, maybe you don't understand. That's why I'll give you another example. Have you ever read my post, "Can you solve this riddle? Zeno's paradox." In that article, I indirectly used the concept of limit, which is the limit of x approaching infinity. Okay. How to solve limit problems. Substitution. For the limit of f of x for x close to a, we can calculate the value of the limit by directly substituting x equals a, so that the limit value of f, so that the limit value is f of a instead. 2, there are times when substitution cannot be done. For example, in the limit problem, so-and-so for x is close to 1. If we substitute directly, the result is 0. Or, well, 0 divided by 0. For that, we need to perform... Well, yeah, that's true. If x is... Wait, no, it says for x is close to 1. It doesn't say x is 1, right? So why would it be 0 then, if x is not... It's not 1 just yet? Am I missing something? For x is close to 1. Wait, for example, in the limit problem, so-and-so... Now, in the limit problem... I'm missing something here. I'm not getting this sentence. For example, in the limit problem, so-and-so for x is close to 1. Okay, so they're saying that this is one of those situations where substitution cannot be done. If we substitute directly, the result is 0 divided by 0. For that, we need to perform... I'm still not getting how the result is 0 divided by 0 if x is close to 1, but not 1. Because if it's 1, then the result is 0 divided by 0, but like, I'm not getting how it would be 0 by 0 otherwise. Anyways, for that we need to perform certain operations that theoretically do not change the value of this function. At the limit, so-and-so, we can translate it into... Oh, are we rearranging the function? Okay. So we get the result x plus 1. Now after that, we can substitute the value of x equals 1 in x plus 1. And the result is 2. So the limit of the function f of x equals so-and-so for x close to 1 is equal to 2. I'm going to need to read that again so I can like just... So I'm able to like imagine it. Limit value of a general function. The general functions referred here are functions such as f of x equals sine x, okay, f of x equals cos x, and so on. The value of the limit of this function is important for us to know because it'll be widely applied to mathematical problems later. Okay. All right. So I'm going to end the stream here. I need to go and read a couple of these other things. I need to read up on solving equations and on linear functions. Where was it? Linear function. It's somewhere here. Linear functions. I think this is it. This is linear regression. This is linear function. So there's a bit of like side reading that I need to do here and there. I'm going to finish that and then I'm going to come back to this. Hopefully I'll finish reading this before tomorrow's stream. There isn't a whole lot remaining, so it's not really going to take time. And then tomorrow I can... Hold on. Let's open this up in a new page. Tomorrow I think tomorrow we're going to start learning about derivatives, the fundamentals of derivatives. Yep. All right. Cool. So, yeah, that's going to be it for today's stream. Let me see if I can find somebody to raid. Let's go into, what was it? Software development. Let's see who is live right now. And go and raid them. There is somebody doing... Okay, there's somebody doing something Godot related. So we're gonna go raid this person. Yeah. Let's go raid this person. So yeah, that's gonna be it for today's stream. Sama, thank you for hanging out and chatting. Anyone else who might have been lurking in the chat, thank you for hanging out. Good night. We are gonna be raiding this person. Yeah, that's it. I hope you guys have a nice day, and I will see you all next time. Peace.